All right. Solving exponential equations, logarithms, and log functions. So logarithms is a big scary word that really just means the inverse of an exponential. That's what a logarithm is. So we are going to work and think about bases that have to be the same. So we're going to do a lot of exponents. So in this lesson, we're doing like 2 to the 3rd power or 4 to the 7th power. Not 4 times 7 or 2 times 3, but raised to an exponent power. So when we are solving exponential equations, if you look at example A, you see that the variable is in the exponent. You guys see that? And I can't work that exponent variable out unless I get the exponent to drop down and be the base. And so what I mean by the base is this letter B. This would be called our base value. So B is the base. What happens from here, bx equals by, to over here where x equals y? What happens between those two things? The what? The exponents become the base, and the base drops out, right? See how the bases drop out? Okay? So that's what our goal is to get the bases to be the same so that then they can drop out. That's our goal. Okay? Is to get bases to be the same. So if we look at example A, I have a base of 3 and I have a base of 81. Can I make 3 become something smaller? For instance, I can make 4 become a base of 2 squared. Do you guys agree with that? 4 can become 2 squared. I could make 16 become a base of 4, which would be 4 squared. Would you guys agree with that? I can also make 16 a base of 2, because 2 to the 4th power, if you do 2 times 2 times 2 times 2, you also get 16. So that's what we mean by changing the base. Okay, so can 3 be changed to be anything smaller? 1. Okay, but 1 to the 3rd power is what? 1. It's not 3. So 3 cannot change. So if 3 cannot change, that's the hint. Then I need to change 81 to be that same base. Put your phone away. Thank you. All right. So if 81 needs to be a base of 3, let's use our calculators. And let's do, I'm not going to pull mine up, but on your calculator you can do 3 and then the little caret button. What is 3 raised to the 3rd power? 27, okay. What about 3 raised to the 4th power? 81, right? And that's what we wanted to. So I can make 81 become 3 to the 4th power. Would you agree that 81 and 3 to the 4th are the exact same thing? Yes. Right? They're the same thing, I just wrote it differently. So equals, I'm going to bring this down, 3 raised to the 2n plus 1. Now, are your bases the same? So what are we allowed to do? Drop that base! Okay, so our bases can drop. And then that means that our exponents become the base. So I have 2n plus 1 equals 4. Is this a problem that you can solve? Yes. Let's do it. Anthony says n equals 3 over 2. Anybody else get 3 over 2? Yep. Good. What that means, well, try your math again. Oh, were you bringing the jokes? Okay, what that means is if I were to plug in 3 over 2 in for my n value, you don't have to do this, just watch. Okay, well, what is 2 times 3 halves? So 2 over 1 times 3 over 2 gives me 6 over 2. What is 6 over 2? 3. So this really becomes 3. What's 3 plus 1? 4. So this is really 3 to the 4th. And what did we say 3 to the 4th was? So this side does become 81 when I plug in 3/2. Okay, so it's the same thing as checking that you always have done since Algebra 1. Plugging in, and you should get the same thing on either side. All right, let's look at problem number B, or letter B. I have a base of 4, which is okay. Can I make 8 become a base of 4? Meaning 4 to the something power is going to give me 8. 4 to the second power is what? 16, right? Because we're not doing multiplication, we're doing exponents, right? So 4 to the second power is too big, which means I can't make 8 become a base of 4. So what might be another option, Brianna? Can you make them both a base of 2? Okay. All right, so Brianna's saying, hey, I can make 4 become 2 squared. So let's go ahead and do that. When I make 4 become 2 squared, I still have the 2x out front. I'm sorry, out behind it. That 2x doesn't go away. It's still there. And then we said 8 can become what? 2 cubed. And I still have that x minus 1. So I don't lose any exponents. They just get written on the outside. Is everyone okay to this point? Any questions to this point? Okay, and now what do we notice? Drop that base. Thank you, Austin. Brianna, was that a giggle when you just said that I wasn't funny? I think that's what happened there.
I was laughing at your attempt to be funny.
Oh, good one. Okay, so let's knock out our 2's. Anybody have an idea what we need to do with that 2 and the 2x? Multiply is an option. Should we multiply or should we add them, you guys think? Our class is divided. If I have x cubed, listen, if I have x cubed to the 5th power, what does that become? X to the 15th, you multiply your exponents in this situation. Because I just completely made that example up. Sorry. I was trying to make an example that was similar to what we have going on down here. So I'm going to multiply 2 times 2x. And this is where some of you are going to get tripped up. We need to multiply our exponents. And so I have 3 times x minus 1. So with that x minus 1, I'm going to have to distribute, right? And some of you would have maybe just put 3x. But instead of 3x, it's really 3x minus 3. Yep, to make 4x. Yes. Okay, now we can solve this problem. This is easy algebra. Subtract 3x over, and I get x equals negative 3. Any questions about that part? All right, the next portion is just transferring them or translating them from one form to another. So it says simplifying and converting exponentials and logarithms. This seems really a lot scarier than what it actually is. Okay, so let's go through this. It says the equation for an exponential function is y equals b to the x. Remember we talked about there was that, we talked about there's really an a there, right? This is really like a times b to the x. But for the sake of this example, we're just going to say it's y equals b to the x. Every function has an inverse. We did that in Unit 3, right, where we did the f negative 1 thing, where we switched x and y. You guys remember that? We switched x and y? Okay. So if I wanted the inverse of an exponential function, I would have x equals b to the y. Please make your y an exponent. X equals b to the y. Yeah. So if we want to talk about what an inverse of an exponential function looks like, we just switch the x and the y. So if you look up here, I just switched x and y, right? This is called a logarithm function. So we can rewrite a logarithm function to look like this. Y equals log base b of x. Please notice that b is a subscript, which means it's the opposite of an exponent. It's a little tiny thing. It's not a power, it's a little tiny base, and you need to draw it as such, write it as such. Okay, so we are introducing this word called log, which is the opposite of exponential. So you're going to be given equations like example C that says log base 8 of 1 equals 0. And you're going to have to change it into exponential form. Please look over here in the gray box. This is log form. This is exponential form. I'll see you tomorrow. Yes. Okay, and obviously it's log form because there's the word log in it, and exponential because there is the word exponential. Put your phone away, please. Thank you. All right, so the best way to do this, because all we're going to do is change it into exponential form. The best way to do this is to label. My formula says log base b of x equals y. And I want to change it into b to the y equals x. So in my equation, what is the b value? Tish says 8. Does anyone agree with that?
Yes.
Look, they're in the same spot, right? So my b value is 8. What is the y value? 0. So I'm going to make 0 be my exponent. What is the x value? 1. So this is changing log form into exponential form. We are not solving anything. We are just rewriting it. And would you agree that 8 to the 0 power, if you were to put that in your calculator, remember anything raised to the 0 power is what number? 1, right? So it is, 8 to the 0 is 1, so it mathematically comes out to be correct. And we just rewrote it in exponential form. So why don't you try part D? And if I were you, I would label, this is my B, this is my X, this is my Y. So I'm labeling B, X, and Y so that I can write it in the proper order into exponential form. No, you're not solving it. We're just practicing rewriting it because eventually we're going to actually have to use it, okay? So our B value is 2. What's our Y value here? And the X value is 1/16. That would be your answer. You're just rewriting it, okay? We're not solving anything yet. We're rewriting it. Questions on that part? Okay, the next set is we're going the opposite direction. So now we're going to be in exponential form, and I want you to put it into log form. Okay, so we're going backwards. We're going the other way. So I know that this is my B value, this is my Y, this is my X. I'm just going to label it. That labeling comes from over here. And I'm going to write it in log form, which means I need to write the word log. Notice how your B is little. Your B should be little. It's a subscript, which means it's down low. I
feel your pain.
I know, right? It's a tough crowd.
Right.
Log base 10 of 1,000 equals 3. Notice that the 10 is little. The log, 1,000, and 3 are all the same size. Please make that adjustment on your paper. Those of you that have large handwriting or unkept handwriting, you need to make sure that you are intentional about this.
Yes, ma'am.
I wasn't calling anyone specifically.
Yes, you were.
There are several. Okay, let's try letter F.
There are several.
Let's try letter F, please.
You know who you are.
You okay? So we have log, what do we put as our base here, Colt? 9. So our 9 is little. Paula, what is our x value? Okay. And our y value is? 1/2. Okay. Questions on that? Rewriting it. Okay, so when I give you an assignment and it says rewrite it, you should go right back to these notes on Monday and help yourself to do that. Okay, let's finish. What, Brianna? Okay, let's finish part 4. So part 4 is going to take us kind of back to what we did at the beginning. When it asks you to evaluate the log expressions, okay, the first thing to do is to set it equal to y. So I have log base 2 of 64. I need to evaluate this. Now, if you look on your calculator, on your graphing calculator, you do have a log button. Do you guys see that? It's on the left side. But we cannot use our calculator to do this because our calculator is programmed to be log base 10. So your calculator is programmed that's always a log base 10. And if you look at example G and H, we have a log base 2 and a log base 4, right? And so using our calculator would not give us the correct answer. So because we can't use our calculator, we have to do a little bit of work. We're going to set it equal to y first. So let's do that. Set it equal to y. And then convert it to exponential form. Remember, exponential form is this. So we're converting it from log form to exponential form. So the 2 is my b, the 64 is my x, and this is my y out here. So this becomes 2 to the y power equals 64. Is that what you guys have?
Yes.
Now, we get like bases like we just did before, and we're going to solve it. So the hint here is that 2 is already the base. So I need to figure out 2 to the what power makes 64. So I'm going to use my calculator. Try it out. 2 to the what power? Let's try the 4th. Let's try the 5th power. Let's try the 6th. 2 to the what power is going to give me 64?
2 to the 6th.
I hear 1, 2 to the 6th. 2, 2 to the 6th.
2 to the 6.
3, 4. Good. So I'm going to rewrite this as 2y equals 2 to the 6th. Remember, we have to get bases to be the same. Bases are the same now. So I have y equals 6. Questions on that? All right, let's do letter H. Tracy, if you need to go, that's fine. Okay, on letter H, we're going to set it equal to y first. Let's do that. Then I want you to change it into exponential form. You can do that part. What do you get when you change it into exponential form, Anthony? 2 to the y equals 1/4. Should be 4 to the y equals 1/4. The y is an exponent. Okay, now I cannot make 1/4 become an exponent with 4. Okay, so here's the hint. Everyone needs to make this announcement on their paper. Change fractions to negative exponents. Change fractions to negative exponents. So what that means is I'm going to change this to be 4 to the negative 1. Do you guys remember if you move it up, you can make it a negative exponent? This is like Algebra 1B maybe, long time ago. Very long time ago. And now what do you notice? Now you got to drop the base, right? Your bases are the same. And we get y to be perfect. Okay, let's just finish I and j, and then I think we'll be done. Okay, I know some of you have to leave for the bus.
I'm actually
5 minutes.
Oh, okay. Okay, we'll be finished with I and j in 5 minutes. All right. Solving equations. So this says log base 9 of x equals 2. I can't use my calculator. What might be our first plan of attack here?
To convert it.
Okay. All right, so go ahead and convert it to exponential. Okay, so go back to your notes that say log base b of x equals y and b to the y equals x. So our b is 9, this is our x, this is our y. So if I change this into exponential form, what does it become, Austin?
9 to the second power,
Equals
y, x.
equals x. Is this something you can solve?
Yes.
What is 9 squared?
81.
So my answer is just 81.
You're right, this is really easy.
Thank you. Sometimes I am right. My husband says all the time I'm right. Just kidding.
Yeah.
He does not say that. Okay. Try letter J. Change it into b to the y equals x. What do we get when we change it into b y equals x, Josh?
You get b to be 11.
No. That was not my question.
Oh.
What do we get when we change it into exponential form?
B squared equals 121.
Perfect. B squared equals 121. Now, if I want to solve this for b, what do we do?
Square root of 121.
Excellent. Take the square root of both sides, remember? We've spent an entire term doing that. So b is 11. Any questions on that? We will finish the next part of these notes in the next video, in the next lesson of notes.